All right, good morning, eighth grade compacted math. Sorry for my look this morning, but it's early and I figured, let's be real, it's a pandemic quarantine day. So, anyways, today we're going to be looking at section 10.2. Excited to graph some more quadratics like we did last week, but this time we're going to add the c value. So, it's going to be ax squared plus bx plus c. So, we'll have to get that line of symmetry that is in the middle of our parabola. So we get the parabola, then we need the line of symmetry, plug it in, that x value to get that vertex, and go from there. So I'm on page 10 of the packet. And so let me just rotate this here. It's going to be upside down for a second here. Okay. All right. So again, the part that we're adding new this week and we're going to get deeper into is that plus C part. Okay, so I'm sorry, not the plus C part. That's what we did last week, was this part. Let me highlight it. The new part here is the BX term. So that's the new part for this lesson. Okay, so a nice little review here at the bottom of page 10 is properties of the graph of a quadratic function. So things that we kind of already established the last couple weeks here is that basically it opens up if our a value is greater than 0, and it opens down if that a value here is less than 0. Now, if a it's a narrow, skinny graph if a is greater than 1, and it's a wider graph if it's a fraction, so a is less than 1, like a could be 1/4 if you had 1/4 in that spot there. So the line of symmetry, we started practicing this on Friday's Hangout and introduced it a little bit last week. The line of symmetry is this part right here. It's where it cuts your parabola. It's completely symmetric, so if you get a coordinate here, you know the same coordinate will happen here when you're graphing. So basically, not only cuts the parabola in half, but cuts your work in half as well. So if anyone remembers it, maybe you do, maybe you don't, but the formula is negative b divided by 2a. So negative b divided by 2a is the formula for the parabola of the line of symmetry. So the vertex has the coordinate of x, so that will find you your x coordinate. So you'll just put, again, same thing, it's negative b over 2a for your x coordinate. So one thing I didn't mention last week that was kind of interesting is that your y-intercept, so remember if we think back, y equals mx plus b, b was your y-intercept. And I can't even think back to quadratics. I can't remember. I think it was your a in the quadratics. It was y equals a times b to the x, I believe, and a was your y-intercept, I believe. Well, now we're even doing it one step further. So in quadratics, the y-intercept is your c value now. So I think if that's true, then we've had a y-intercept of a b, and now a c. It sounds like alphabet soup. So basically, so again, if you think of your format, whatever that c value is, we saw that last week too, that is your y-intercept. So you can even see written here, 0 comma c is your y-intercept. So we would put, so the point 0 comma c is the y-intercept of your parabola. So if I just had y equals 2x squared minus 5x minus 8, then I know that my y-intercept, there would be a coordinate as 0 comma negative 8 for my y-intercept. So that's important to realize there. All right, so turn the page to page 11. So for today's lesson, we're going to go through each example. You can pause the video, do the checkpoints, and you're going to enter your answers to the checkpoints on Google Forms. I won't make you take any pictures today. You'll probably just end up putting the X line of symmetry and the vertex and maybe one coordinate. So you're only going to have to graph one of these checkpoints for today's lesson. So here goes. We are going to, for our first example, graph this quadratic. So it's negative x squared plus 4x minus 1. So the first thing you do before you even start graphing is you have to look at the a, b, and c. And you have to identify some of the basics of the parabola. So the a here is negative 1, the b is 4, and the c is negative 1. So automatically knowing this here, I know that the parabola is going to open down because a is less than 0. So I automatically know somewhere in this area I'm going to be opening down. So that means I'm going to have a maximum vertex because it's going to be at the top of the parabola facing down. So step 2, let's find the line of symmetry. So I'll do this here in green, I guess, just to kind of keep it color-coded. So I'm going to write this in negative. So my b is 4, negative b, or negative 4, over 2 times a, negative 1. So that at the bottom, it's going to be negative 2 over negative 4. So I know that my x is equal to positive 2. So my line of symmetry, I'm going to go right here, and I have a line of symmetry at x equals 2, a vertical line of symmetry there. So now to find the actual vertex, you're going to take the x-coordinate of the vertex, which is, of course, 2, and we're going to substitute that that 2 for x in the function, and then simplify. So I'm going to put, again, this is our function I'm substituting it into. I'm going to put negative 2 squared. Now notice the negative's on the outside when you square it, so it's going to give you a negative answer. And 4 times 2 minus 1 equals 3. So when I simplify that, I'm left with negative 4 plus 8 minus 1. And negative 4 plus 8 minus 1 is going to be, that's 4 minus 1, which is 3. So my vertex, so my y-coordinate, so I get y equals 3. So my y-coordinate I'm going to put there is 3. And my x I already knew was 2. So now I'll go ahead here. I'm going to go to 2, comma 1, 2, 3. And there's my maximum. I'm going to talk about this later in the lesson. That's a maximum because I know already it's going to be facing down. So it's a maximum vertex. So I plotted the points. Number 5, we are going to, number 4, we're going to choose some x values. And remember, you can see I'm just choosing x equals 0 and x equals 4. But this is going to produce 2 other points because it's going to be on both sides of the line of symmetry. So when I put in x equals 1, if you don't mind, I'm going to do some mental math here, hopefully. So that's negative 1 plus 4. I shouldn't do mental math. I want you to see it. So I'll do y equals negative 1 squared plus 4 times 1 minus 1. So I get negative 1 plus 4 minus 1. And so I'm going to get, that's 3 minus 1, which is 2. So I'll put y equals 2 there. And then the 0, okay, I automatically know my y-intercept. The y-intercept is the c value. So I know when I put in x equals 0, this is going to be my y-intercept, negative 1. So I go there and I put a dot. Okay, so now I'm going to actually plot the points. So the points plotted in step 4, I'm going to put them on the other side. So let's just plot these points. So I have the coordinate 1, 2. So 1, again, that came from here, 1, 2. So 1, 2 would be here. Okay, so now I can get on the other side of my parabola by goes one spot from my line. So I go one spot from my line here, and I just got 3, 2 for another one. Then my y-intercept is 0, negative 1. And that's 2 away from my line, 2 away from my line here. I'm really tempted to see what I won't do it. Probably goes off the graph, but I kind of want to put in x equals 5 to see what it gives me. But I'll just assume you want to do that on your own, but I'm assuming it's going to go off the graph if it didn't make us do that. So now I'm going to draw my smooth curve, my smooth parabola the best I can here. Now it's graphed. Not bad, right? Okay, so for this checkpoint, I'm going to have you pause the video, and I want you to graph this one the best you can. On the Google Forms for today, all you're going to input, you'll see there, I'll put for checkpoint number 1, I'm going to ask for what is the line of symmetry, x equals, and then I'm going to want the vertex, and then I'm going to want you to insert at least one coordinate that you find on your parabola. So maybe the coordinate you'll just type it in like that. So good luck with that checkpoint graphing this line, this quadratic. I'll tell you right now, it looks like it's going to be facing up. And just be careful when you're doing this here. You can see the x values are increasing by 1, but our y values are 3, 6, 9. And so on by 3s. So good luck with that one. Example 2, I should say. So here, this is the part about the minimum and the maximums that's kind of important. So basically, you get a maximum vertex if the a value is greater than 0, because, I'm sorry, not greater than 0. No, yeah, well, I kind of messed that backwards, sorry. It's a maximum if a is less than 0, because if a is less than 0, you're going to be facing down, so you'd be at the very top of your parabola. You'll get a minimum if a is greater than 0, because over here you'll be facing up, so your vertex, the bottom parabola, will be the minimum vertex value of your entire function. All right, so let's do another example here. It says find the minimum or maximum value. Tell whether the function 5x squared minus 20x plus 17 has a minimum value or maximum value. Then find the minimum or maximum value. So I already know, because a equals 5 and is greater than 0. I already know the parabola is going to face which direction? Up. So I know the function has a minimum value. To find the minimum, I'm going to find the vertex. So to find the vertex, we have to use that formula here. So I'll identify at the top my A, 5, my B, negative 20, and my y-intercept, my C is 17. So here goes. Negative B. So negative B would be negative 20 over 2 times A, 2 times 5. Okay, I'm just plugging those numbers in. 2 times 5 is 10, and negative 20 is positive 20, and 20 divided by 10 is 2 again. All right, so to actually get the vertex, I'm going to plug in to my f of x, which is the same thing as, remember, f of x is the same thing as y. So I'm going to plug in 2 to all my x's. 2 squared is 4, and 4 times 5 is 20, minus 40, plus 17. So that's going to be negative 20 plus 17. It's negative 3. So I know my y equals negative 3, or my f of x equals negative 3. So to finally answer this question, I'm going to write the minimum value of this function is at the vertex coordinate. Here it comes. Remember, my x was 2, and comma, negative 3. So that's kind of similar to the other one. The other one was 2, comma, positive 3. So that's how I'd answer that one. For the next checkpoint, you are going to tell whether the function negative 1/2 x squared plus 6x plus 8 has a minimum or maximum, and then figure out that minimum or maximum by telling me what the vertex is as a coordinate. Okay, so again, you'll put that on the Google Forms. For the rest of today's half-hour lesson, it might take you a little bit over a half hour. I wanted you to watch that other video that I sent to you earlier last week when I think after Wednesday's hangout. And basically, I'll write it in there. If you want to quickly just pause it at 4 minutes and 6 seconds and 7 minutes and 40 seconds, and before he does the line of symmetry and the vertex, maybe you can try it on some scratch paper. And then I think I also wanted you on page, I think it's the next page, 13. Just try a couple of these and put them on the Google Forms. It shouldn't take you too long. I wanted you to try just kind of like some nice easy ones. It says tell whether the graph faces up or down and find the axis of symmetry, so your x equals, and the vertex. So maybe just try 11, 12, and 13 and put it right on the forms. If you're spending way more than a half hour and you can't get to 11, 12, and 13, that's fine. But I figured we'll see. That's a good start for today, and we'll do our Google Hangout tomorrow on Wednesday, the 22nd.